Hey there, everybody. I'm going to start doing this live stream here in just a couple of minutes. This time we're going to be talking about function composition when you want to write a new rule. We'll do another video later on when it's a simple number input and output. The reason I'm doing this one first is that a lot of my students prefer using this method to do the other one. So when we get to that video, we're going to do two different versions of it. But for right now, we'll get this one going. So I'll get started in just a minute or so. All right, we got one in. Hopefully the rest of my students will have the opportunity to take a look later. All right, let's go ahead and get going here. Function notation. All right, let's just get some vocabulary out of the way first. This says f of x. F of x. That's how you read that. This is not some sort of multiplication symbol. This is, again, function notation. Let me make that f look a little bit better. There we go. This one here, function notation, this would be read as g of x. Alrighty, and then finally, function composition, this one right here, this is going to be called f of g of x. In other words, if you look at these outer parentheses, we basically just kind of put g inside of it. All right, so let's go ahead and do one. Pretty much the rest of this is just examples. And what we're going to do is we're going to start by writing f, okay? But I have this on the right hand here. This is kind of the linchpin to the whole thing. But every time I see the letter x at this step, I'm going to replace it with nice big empty set of parentheses. So f of x, which is 2x minus 5, it's going to become 2x minus 5. I replace the x with the pair of open parentheses. Alrighty? And then inside those parentheses, just like how g of x is inside the parentheses here, I'm going to put it inside those parentheses. Alrighty? Okay. So what we're going to do here, it's really just straightforward. We're going to simplify, okay? You're going to distribute that 2. So you're going to get 6x plus 8 minus 5. Combine your like terms, 6x plus 3. And there you go. We can say that f of g of x equals 6x plus 3, the end. Okay? Now, what you might have to do is this one here. This is the reverse. This is g of f of x. Okay, since f is right here inside the parentheses, we're going to take f and put it inside the parentheses. Same deal, we're going to do 3x plus 4. Okay, we replaced the x with nice, happy set of parentheses. And inside we'll put 2x minus 5. Alrighty. Same as before, we just simplify, distribute. We've got 3 times 2x, that's going to be 6x. 3 times neg 5, that's minus 15, plus 4. And then combine like terms. That's going to be minus 11. So g of f of x is going to be 6x minus 11. All right, that's pretty much all there is to it. Everything else is just going to be variations on that theme. All right, here I am going to talk about another notation. You read it exactly the same way, and if you don't really like the way it looks, change it. It's no big deal. This right here is still p of t of x. Okay? If you don't like it written this way, the letters stay in the exact same order. You can write it as p of t of x. Okay? Now, once again, since t is on the inside, that's going to go inside the parentheses. The x for p is going to become a nice, happy, open set of parentheses. So we've got 3x, that's our x, minus 4. Inside there, we're going to go ahead and put the other one, negative 2x plus 5. Step next is to distribute. That'll be negative 6x, and that'll be plus 15 minus 4. Combine like terms. And there you go. Final answer, we're going to say p of, I don't know what that was about to be. P of t of x. Again, if you're not a big fan of that notation, you can use the other one there. They mean the same thing. This one, I think, is a little bit more intuitive, though. All right. Well, since we did it in reverse last time, we're going to do it in reverse again. This time it's p of t of x. All righty. So we're going to take, wait a minute. I don't know why I wrote that. That's the exact same thing. Well, I guess we're not going to do that one. That was a mistake on my part. So let's just move on. Nonlinear. Okay, everything that we've done so far has been a linear equation. This time I'm incorporating a quadratic into the mix. Alrighty. It's j of r of x. If you want to rewrite that, that's j r x. J is what we're going to start with, and it's going to be x. Remember, we replace the x with parentheses. Squared minus 3. Inside the parentheses, we're going to put r, which is x plus 5. Okay, we're still just simplifying. The only thing here is it is going to take a little bit more work because we are squaring a binomial. If you happen to have ever been taught the a squared plus 2ab plus b squared formula, you can go ahead and just kind of knock that out super fast. If not, I recommend using box method, essentially a Punnett square. We'll go ahead and put x plus 5 on the outside here, and an x plus 5 on the outside here. And every box is going to be the product of its row and column. So here's going to be x times x or x squared. Here's going to be x times 5 or 5x. Over here will also be x times 5, which is still 5x. And then 5 times 5 is 25. All right, so if I write that whole thing out, it's going to be x squared plus 5x plus 5x plus 25. Pretty much all the time, these two guys are going to be like terms, okay? So you've got x squared plus 5x plus 25. Now, I know we did a lot of work just now, but don't forget what our original issue was. We're doing this. We only did this part right here. There is still this minus 3 that we have to contend with. Okay? Combine like terms. X squared plus, why did I put 5x there? Oh, that's better. Plus 10x plus 22. And that will be our j of r of x. Okay. Now the reverse is actually going to be a lot simpler because the thing that we're plugging it into isn't a quadratic. This time r is on the outside. So it's just going to be x plus 5. And then we're going to go ahead and put j inside of it. X squared minus 3. Those parentheses, they're not really doing anything. So we can just drop them. X squared minus 3 plus 5. And combine like terms. And since this one was in that notation, I'll keep it that way. R of j of x. And there you go. All right. Okay, let's just do a couple more, and then we're going to be all set. This time here, the only other thing that I haven't mentioned yet, and we're just going to do one more problem, is if we have multiple x's. Okay, I've had this question come up before. This time, w is the one on the outside. We're doing w of h of x. Okay, since w is on the outside, that's the one we're going to replace every instance of x with some nice open parentheses. Okay, so we've got two sets of open parentheses this time. Now we'll put the other one inside here in both sets, x minus 3 over here, x minus 3 over here. Okay, and we simplify. The left part, that is once again working with a binomial squared. If you know the shortcut in order to get, what is that, x squared minus 6x plus 9, you can do it that way. If not, go ahead, use the Punnett square. If you're a fan of FOIL, you can do that one too. X squared minus 3x minus 3x, and then a positive 9. And again, these two are like terms. So you're going to get x squared minus 6x plus 9. The part on the right, it's just distributing. So you're going to do 2 times x and 2 times neg 3. Almost done. We just need to combine like terms. We've got the x squared. We have a negative 6x and a positive 2x. That'll be minus 4x. And then we've got a 9 minus 6. So that is 3. And there we go. In this instance, that will be w of h of x. If you wanted to, if you're a fan of that other notation, it could have been written this way, okay, depending on how it shows up for you. But guys, that's pretty much it. Didn't look like I had any questions coming up as we were doing this today, so hopefully you're good with that. I'll have conferences later during the day, and later on in the week we will hit doing the same thing but evaluating at a specific number rather than writing a new rule. All right, talk to you next time.